Hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I am here to solve that section of maths which is one of the most high weightage in nature, means each question is worth 5 marks and also somewhat easier and predictable in your syllabus. Okay, so again this question that I have taken today will be as per your blueprint, means whichever chapter has the questions coming or mentioned as, I'm gonna take and solve those chapters problems only. So the questions which I'm gonna take will be from your question bank, the latest one, as well as your PYQs. So pay attention, solve all these questions with me, and certainly you'll feel much more confident once the class is over about your 5 marker section. Okay, so this is clear. Can I start the class now? Yes. Now before I start, I have a surprise, a gift for all of you, and that is regarding your free 4 KCET mock test. Okay, so I know that many of you, already availed this offer. Okay, if not, I've taken a sample of one of the classes that I have given to all of you, which is of integrals in master stroke. Similar to this, even in this class, if you go and check the video's description, you will find the link given like this as free KCET PCMB mock test PDFs. Click on the link, fill in your details and get all the PDFs of all 4 chapters with question and also detailed solutions. So don't wait right now, okay, and get right away this PDF for your own practice of KCET. Again, this is for KCET mock test. Free 4 mock tests are given to all of you. So take the advantage and take this particular question set for all of you. Okay, now one of the most important chapter in your syllabus worth 17 marks has a 5 marker. Yes, and that is continuity and differentiability. A very easy question. I think the easiest of all 5 marker comes from this chapter. Simply a second order derivative question comes and we're going to solve it. I have taken very varieties. You'll see right now. I have taken all the varieties over here. You can see. Yeah. So we'll see and solve all the variety of questions. Now before I start, do not forget to join me. How can you join me? Simply by subscribing to our channel Deeksha Karnataka and giving a like in this class if you appreciate what we're doing over here, if you find this helpful. If you don't, let us know why it is not helpful and we'll help you figure out and we'll help you with the approach that you need from our side. Okay, question number 1, beta. Question number 1. Okay, so this is a given function. I have to prove this equation that is correct or not. Okay, so let's check from here. I have to go what? Find first and second derivative. So I'll do the first derivative first. I can write this as y1. I hope you don't mind because y1 is same as dy by dx. Cool. Differentiate this. We'll have derivative of cos as negative. So minus 3 sine of, what is this? Log x. And is this over? You have to differentiate log also by chain rule, so you'll have divided by x. Same with the second term. Sine derivative is cos, so plus 4 cos. Again you'll have log x, and derivative of log is 1 by x. Take x common and move on this side. You'll have xy1, and on this side we have minus 3 sine log x plus 4 cos log x. Correct. Now differentiate the same equation for the second time. So you'll have to apply product rule over here. Let's do that. So if you differentiate x, you'll get simply 1 times of y1. But when you differentiate y1, you have to keep x as it is, and y1 becomes y2. Derivative of first derivative is second derivative. Okay, sir. Differentiate this sign now. It becomes cos. So minus 3 cos log of x, and derivative of log is 1 by x. Same fashion, cos derivative is minus sign, so put a minus sign. Minus 4 sine log of x, and derivative of log is 1 by x. Now take x common with the minus sign and move on this side. You'll have I can take minus 1 by x common. Minus 1 by x common, check carefully. This becomes 3 cos log x and 4 sine log x. 3 cos log x and 4 sine log x. So basically the function y itself, now cross multiply. This is y1 plus xy2. If you multiply x on this side, you'll end up with xy1 x square y2 equals to minus y. Rearrange this, beta. Rearrange this. So I'll write the second derivative term first, means in the beginning. So x square y2 plus xy1, excuse me, 1 second, plus xy1. okay, and then comes plus y equals to 0. This is your answer. I hope this is clear. Okay, if you are not able to relate with this, it's okay, I can help you with that also. X square, I'm going to rewrite this equation. X square is x square. Second derivative can be written like this as y2. This is plus xy1. And what is this? Plus y. And check, this is same what I've done over here. And like this, you solved a very simple question in 5 marker. And yeah, if you see the previous 10 years papers, you'll find a question like this appears in the examination. If not like this, then how about like this? Even this is also very relevant. So question number 2. If you have y equal to this, you have to prove that this is the required condition for second derivative. Same approach, y1. You'll have 500. E power 7x remains as it is. Differentiate 7x by chain rule, you will have into 7, same way. 600, e power minus 7x remains as it is. You differentiate minus 7x, you will have minus 7 over here. No problem, sir, no problem. Differentiate this again, you will have 500, e power 7x is there, and into 7 we already have. Remember, this 7 I have kept it in the front. Differentiate e power 7 again, you will get 1 more 7 plus sign. 600 we have. E power minus 7x also we have. This minus 7 we have. If you differentiate one more time this thing, you'll get 1 more 7. Sir, what are you saying? Sir, what are you saying, sir? Think about it. Think about it. Be logical. Differentiated e power minus 7x, you got e power minus 7x into minus 7. Differentiate one more time, you'll get e power minus 7x into minus 7. So you're getting 2 times. No problem. So we have 7 square over here. That's 49. Okay, and into 500 e power 7x, that's my first term. Over here you check, same way, minus 7 into minus 7, that also is 49, and we have 600 e power minus 7x, and then you take 49 common, and you end up with what? 500 e power 7x plus 600 e power minus 7x. The answer is nothing but 49y is the second derivative. Is the second derivative. So this easy? Yes, that easy. Question number 2 is also dealt with. Question number 3 is a second order derivative question on the parametric form. So we'll have to have a structured approach in this. Steps matters, beta. Each question is worth 5 marks. So steps matter. Okay. So we'll go about this question starting with the first step, that is finding derivative in parametric form. Is this dy by dt upon dx by dt. Okay, let's find it individually. Dy by dt we'll find first. Let's find dy by dt first. Differentiate this. A is a constant, so it's outside only. Sin t becomes cos t. There's a minus sign over here. And t, if you differentiate, you'll get 1. Cos will remain cos. Now you go and differentiate in the other way. Keep t as it is. Differentiate cos. You get minus sin t. Right? Simply product rule. Nothing else I've done. Check here. Cos and cos cancels. My answer is coming as a. And this is what? Minus into minus. This is minus into minus. That becomes how much? That becomes simply. Check here. This becomes what? Simply minus into minus is your 1 second. This bracket is missing. I'll rewrite the bracket part. This is the bracket which is missing. Okay, minus into minus, so becomes plus. So plus t sin t. So at sin t is the value of my dy by dt. So this makes sense, sir. This part makes sense. Be patient, okay? We have to write all the steps to get all the marks. Simple questions, we cannot lose marks over here. Next question will be, next step is finding dx by dt. This is important, so please pay attention. Here, a is a constant, keep it outside. Cos will become minus sign t and plus as it is. Differentiate t this time, you'll get t as 1 and you'll get sin as it is. So sin t comes a plus sign. T as it is, differentiate sin, so you get cos t. Close the bracket. Is that it? Have a look. So minus sin t and plus sin t is cancelled. what I'm left with actually here is dx by dt is coming out as a t cos t. Check here, a t cos t. So if I want to write, just telling you why later, dt by dx, what I'm going to get this value as? Simply 1 upon at cos t, or you can write this as secant t by at, 1 upon at cos t. You'll see, don't worry. Okay, let's go to the next step. What is the next step? Adding it together, dy by dx. This becomes, if you write them together, these values, this by this. So you have at sin t upon at cos t. So at cancels. This is what? Tan of t. So my dy by dx is coming as tan t. Tan of t. Differentiate now. D square y upon dx square. Right? This will become derivative of tan. So secant square t. Is it over? No sir. Chain rule. dt by dx, and we have that value. Okay. In that case, this answer becomes, check here, secant square t into dt by dx will be what? 1 upon a t cos t. Bring this cos up, it becomes secant again. My answer comes out to be secant cube t upon at. Secant cube t upon at. This is my final answer. Please check. This is my final answer. Secant cube t upon at. Correct? Next. Simple question. Just few more steps because it's use of parametric form also. Question number 4 now. If y is this, and basically I have taken all the varieties which is possible to secure that 5 marks in continuity and differentiability chapter. Agree? Good. Y is given, so that this is true. Same approach, we want to find y1 first. So I get 3 cos. I've done a similar question like this, no? I think the same question I've done. Here was this. Yeah, 3 cos log x, 4 sin log x. 3 cos log x, 4 sin. Yeah, same question, sorry. This was a p by q also, that's why it has repeated 2 times, okay? P by q and also part of question bank. That is repeated both the times. This is a p by q and also a question bank. So this is done, sir. Done, and same as question number 1. Now moving to question number 5. Even though question number 4 is same as question number 1, but yeah, all right, not a problem. Now a good question. This is a 5 marker question in particular functions. I know many of you want to skip integration, but it's not my job to tell you to do that, because I would love to have you answer the questions of integration as well, because they're not difficult. I'll show you. This is a very good question that I'm going to show how to solve it. So it all depends upon, if you remember, I've given a list of substitutions in trigonometry in the cases of roots or fractions or rationals, whatever it is. So whenever you find x square plus a square in the root, you simply take x as a tan theta, differentiate dx as a secant square theta d theta. Now you check the integration. The integration is given as I equal to integration of 1 upon root of x square plus a square dx. Use the substitution that we have made. Dx becomes a secant square theta d theta divided by, in the root we have what? A square tan square theta plus a square. Continue. A secant square theta d theta. Take here, if you take a square over here, inside becomes tan square plus 1, nothing but secant square theta, and this whole thing is in the root, right? This whole thing is in the root. So clearly we have an answer now. This is I. This is the answer. Have a look. So the answer is coming out to be integration of, we have a secant square theta d theta, numerator is not changed, denominator is what? A secant theta, a secant theta, there is no d theta, sorry, yeah, correct. How come, sir? A tan square plus a square is there, you can take a square common, it becomes tan square plus 1, that is secant square, and a cancels, secant also cancels, integration of secant theta d theta is what? You should know the formula, log of secant theta plus tan theta, log of secant theta plus tan theta, and of course plus c will be there, the constant of integration, the constant of integration. If you've taken x by a as tan theta, x as a tan theta, it means clearly tan theta is what? X by a. Not a problem, sir, not a problem. Tan theta is x by a, not a problem. What about secant square then? We know that 1 plus tan square theta is secant square theta, correct? It means secant theta would be root of this value. It means secant theta will be root of this value. Tan theta we already have, which gives me the result very simple, that secant theta becomes root of 1 plus x square by a square, because we're going to square the tan, so x square by a square. Simplify this, a square plus x square by a square. Simplify this, a square plus x square in the root by a. This is the value of secant theta. This is the value of secant theta. Now club them together and write the answer. You'll have integration as log of, check, root of a square plus x square by a plus x by a plus constant c. You can club them together, you get log of, check this out, you get x plus a square plus x square by a plus c, log of a by b. The formula is very simple, log of a by b is given as log of a minus log of b. So log of numerator minus log of denominator, so this will become what? Minus log of a, and log of a will be a constant, let's say c1. So I can write this now, log of, check this out, x plus root of a square plus x square minus log of a plus c, and log of a and c means this value, c minus log of a can be taken as a constant k. So my answer is basically the integration I equals to log of x plus root of a square plus x square plus the constant k. You might feel this is lengthy, you might feel this is difficult, but it is not. It is not. I have made it lengthy because I don't want to skip even one step. Okay, none of the steps are skipped. So what is the crucial steps in this particular question? Starting from the substitution, which is important. Derivative you don't know. Which step is difficult? Substitution is difficult. Is the derivative difficult? Is the substituting in the question difficult? Okay, or is it getting the result of this as integration of secant theta d theta as difficult, or is this formula difficult? Once you know tan theta value, can you not find secant theta? Is it difficult? This is something you did in class 10th. Okay, from one ratio is known, you can find the other ratios, right? So secant theta is there, you find this value. Once you get this value as, so I've written everything step by step, phase by phase, which will help you get out of out marks in 5 marker if this question comes. So first part, again, yeah, this is important. Only first part is over. Second part, the question also is there, which is dx upon, integration of dx upon 1 plus, I can write 2x the whole square. 1 plus 2x the whole square. Okay, now in this, so take substitution as 2x equals to t. Differentiate 2 dx equals to dt. It means dx equals to dt by 2. If you're thinking this part is difficult, not allowed. It's very simple actually. Think about it. You get dx as dt by 2. So 1 by 2, you're going to keep it outside. Okay. And this whole thing becomes inside the integration 1 plus t square. This is the same form, please check. In this case, a is what? A is 1. Okay, so answer is going to be what? Check here. 1 by 2 log of x. So in this case, t plus the same root repeats, 1 plus t square plus c. Now put the value of t back. So log of t is 2x, right? 2x plus root of 1 plus 4x square plus c. That is it. 5 marks is done. And it's very satisfying to get it right, because this is a little bit challenging in nature, but we can do it because we have learnt it. I have taught all of you. Okay, so I keep telling all of you that the chapter that I'm teaching, integration, leave it to me, and I have prepared all of you regarding this step by step, question by question. So you go in this approach for this particular chapter. Do not leave it out standard. Now again, I want to tell you all about your KCET 30 plus batch. It's already live. Many have already enrolled. Do not miss out the opportunity to get both the access of ABHYAS test series and KCET 30 batch together at a price of 3,999. Offer is only valid till 25th February. Okay, this is a 30-day crash course alongside the mock test for KCET that comes with 35 mock tests across the subject, physics, chemistry, maths and biology. You also get in this so if you take this course right now, you get the access starting from 21st March, but the access of ABHYAS test series comes right away. Okay, and now if you check over here, this is just KCET 30 batch. If you don't want to take a ABHYAS test series, which will be a mistake, but if you want to just go with the KCET 30-day crash course, we're gonna teach everything from from basics to the higher level of KCET in this particular 30-day live online crash course. KCET previous year questions will also be given as a solution, means you're gonna get an entire solution of all the questions. You also get complete syllabus coverage, as I mentioned, PU1, PU2. You also get chapter wise KCET PYQs. You get to attempt the PYQs as a live test. Okay, and alongside all of that, you get 10 full length KCET mock test. This you have to take it today if you want to avail that price, because this offer gonna end. This is a Vidyotsav offer going till only 25th February, and this particular batch will be available to all of you on 21st of March. Offer is there till 25th of February. Batch start on 21st of March. Clear, guys? Okay, done? All right, cool. So this is clear. Next question. This was question number 6, I guess. Question number 6. 5th we did right before. This is question number 5. Then this is question number 6. All right, sir. So find the integral of this question. This is a very simple problem. What is this? Application of partial fractions. I'll show you. So write this fraction that you have as this 1 upon a minus x and a plus x. Now I think it makes sense to all of you. Can you not find this value? Of course you can. Write like this: 1 upon a minus x, a plus x as a upon a minus x and b upon a plus x. Okay, if you simplify this, you're going to get a times of a plus x plus b times of a minus x. Okay, and if you just compare the numerator, I think that will be enough. Don't worry about the denominator, it will be same, of course. Okay, now in this, take x value as a. You're going to get the LHS is equal to 1. This does not change, this is 1 only. This becomes a into a plus a, which is 2a. This will be 0 because a minus a is 0. So you get the a value as 1 upon 2a. Same way, if you take x value as minus a, x value as minus a, sorry I wrote it ulta, but yeah, x value as minus a, when you do that, you'll have LHS minus 1 only. This will become a times of 0 and it'll be minus a and minus a. So it will become plus 2a, no? Excuse me. If you take x value as minus a, this is a minus x, right? Yeah, so a minus x, a plus x. Okay, when you take x value as a minus a is cancelled, so this is going to be 0. We have something I missed. A square minus x square, that's correct only. Yeah. So when you do that, you'll have this value as, please check, you'll have this value as a when you put x as minus a. This becomes minus a plus a, which is 0, and minus a minus of minus a becomes again same thing. You'll have the value of this as b times of 2a. So you get this as p equals to 1 upon 2a. 1 upon 2a. Something doesn't make sense. Something is missing. I'll check. Okay, don't worry guys, I'll check. This is question number 6. Okay. and let's use it over here. You get this integration in the form of integration of I will become 1 by 2a. What is this? Yeah, what is this? 1 second. A minus x. A minus x. Excuse me. Sorry. Yeah. This is 1 by a minus x, no? My bad. 1 by a minus x dx, and plus b value is also the same thing. 1 by 2a, 1 by a plus x, and we have dx. Correct, right? So far so good. Now if you integrate this, you'll have the integration I as, check here, 1 by 2a is a constant. This becomes ln of a minus x divided by minus 1, because you have to see the coefficient of x, right? So here coefficient of x is minus 1, you got to divide by minus 1. You know that, right? Yes. And in this case again, 1 by 2a ln of simply a plus x, don't worry about that, and of course the constant c will be there. Take this 1 by 2a common outside. What you have is, I'll write the positive side first, ln of a plus x minus ln of a minus x plus c. So my answer is clear now. I equals to 1 upon twice of a. Write the log directly, log a minus log b. So a plus x upon a minus x plus c. This is your integration's final answer. This is a particular function's result. Got it, guys? All the steps are clear. I hope it makes sense to all of you. Next is the second part, sin x upon 1 minus 4 cos square x. Next is what? Integration of sin x upon 1 minus 4 cos square x dx. Okay, now in this, write it like this: sin x upon 1 square minus 2 cos x the whole square dx. Now take this 2 cos x as t, you get the answer as 2 minus 2 sin x dx as dt. It means sin x dx as minus dt by 2. Sin x dx as minus dt by 2. Okay, you have the result now. Check this out. This becomes sin x dx as dt is there. There's a minus sign outside, and of course minus 1 by 2 is outside actually. 1 second here. Sorry, I made a mess. Good. Okay, minus 1 by 2 dt, and we have 1 minus 1 square minus t square. Now we have the answer for this. Simply 1 by 2 is a constant outside. 1 by 2a, so 2 into a value is 1. Log will come ln, what was it? A plus x or a plus t upon a minus t plus c. If you remember, a plus t upon a minus t, x is there, so it will become t in that case. Final answer in terms of the variable, minus 1 by 2 into 2, this 2 will come over here, right? So 1 by 2 into 2, let's write this as directly 4 by 2. Have the confusion. 4 ln. Now check. A plus t. T value is what? 2 cos x. So a plus 2 cos x and a minus 2 cos x. A minus 2 cos x. Correct, na? Yeah. A minus 2 cos x, correct? Yes, and plus c. That's your answer. This is the answer. Have a look. 5 marker. Question number 5 and 6 are both done. Okay. Question number 7 now. This one I have already solved it in your top 50. So I'm going to give you a hint to this, but I'll now solve this completely. What is the hint for this question? Simply in this integration that you have 1 upon a square minus x square dx, take x value as a sine theta. A sine theta, right? Yeah. When you do that, differentiate it, you're going to get x dx as a cos theta d theta, and this will become what? I equals to a cos theta d theta, and you'll have over here integration of a square minus a square sine square theta. Solve it. Solve it. This will become a square 1 minus sine square theta, that is a square cos square theta. Root will apply, a cos theta, same in the numerator will cancel. You'll have simply integration as d theta. Answer becomes what? Theta plus c. Check here. Theta value will be what? sine inverse of x by a is the value of theta. Got it? So please solve this question, guys. Okay, solve this question. So in this, solve it completely. And if you talk about the last step, it will be like this: dx upon, excuse me, root 7, no? Root 7 the square minus x square. The answer become what? Sine inverse of x upon root 7 plus c. Please check. Have a look. It's not complete. This result is not complete. You have to solve this one. I've given the major hints, all the steps, but it's incomplete. You have to solve it completely. Okay, done. Question number 8 now. Question number 8. It says find the integral of this function. Again, similar question. I remember doing it. So go ahead. As I mentioned clearly, beta, that I am taking all the variety possible for the proof of this 5 marker, because I mentioned this clearly to all of you that I'm going to take care of your integration. I know many of you wanted to skip it, but I asked you not to skip. I'm going to take care. I'm doing that in my classes. Okay, take x as a tan theta. You'll have derivative as dx equals to a secant square theta d theta, right? Okay, now if you put it over here, you'll have the value as a secant square theta d theta divided by a square tan square theta plus a square, right? So we have a secant square theta d theta. Take a square common, you'll have tan square theta plus 1. Tan square theta plus 1, that is secant square. So this is cancelled. A is also cancelled with one of the a's. My answer is coming as I equal to, integration means 1 by a is a constant outside. We have only d theta left. So I is coming as 1 by a theta plus c. Theta value you check now. Theta value is tan inverse of x by a, because a will come over here first, so x by a, tan inverse will operate. So I becomes 1 by a tan inverse of x by a plus c. Tan inverse of x by a plus c. In that question, is it difficult? Not really, right? Not really. Please check. This one, take 2 common and the question will solve. Take 2 common. Integration, 1 by 2 is outside. Check here. X square plus 25. The answer becomes 1 by 2 is outside. 1 by a means a value is 5 over here. So 1 by 5, because 25 is there, no? So that is 5 square. And tan inverse of x by 5 plus the constant c. It will become 1 by 10 tan inverse of x by 5 plus c. Question number 9 now. Question number 9. Does it make sense, guys? Does this make sense? Yes. Question number 9 now. Relation and functions, a very good question. It's a 5 marker. So after, I would say, C and D, after continuity and differentiability, the second question which is easy is from 5 marker of relation and function. Okay, let's see. They have defined the domain, and codomain A is the domain R, all R except for 3, and the codomain is all R except for 1. Okay, A is what? Sir, let's write it. A is the domain and B is what? B is the codomain. Right, and they're saying that the function defined from A to B, of course, that is clear. Now they're saying that fx is given like this, prove it whether it is 1 1 on 2 or not, and if it is, justify your answer. So first one is to go for 1 1 proof. Okay, in that what we do, start from f of x1 equals to f of x2. If we reach x1 equals to x2 means it will be 1 1. Okay, sir. Done. Start here. x1 minus 2 upon x1 minus 3, and we have over here x2 minus 2, excuse me, x2 minus 2 upon x2 minus 3. We have to, of course, cross multiply, expansion will do. So x1 minus, I can do the same thing together. Okay, I can do the cross multiplication and expansion together. So x1 into x2, that is one term. x1 into 3, so minus 3x1. Now you check. Minus 2, I have done this multiplication with both the terms. Now I'm going to go and do with minus 2. So minus 2x2 and minus 2 into 3, that's plus 6. I'll do again so that it makes sense to all of you. x1, x2, x1 into 3, minus 3x1, minus 2 into x2, and minus 2 into minus 3 is plus 6. I'll do the other side now. x1, x2, x1, x2, x1 into minus 2, that's minus 2x1, minus 2x1. I've done x1 with both the terms, x1, x2, minus 2x1. Now minus 3x2, minus 3x2, and plus 6. And plus 6. And plus 6. Check here. This is cancelled. x1, x2 is cancelled. Okay, the remaining terms now. I have minus 3x1, so I'll move this term over here, and minus 3x2 I'll move it over here. Got it? Now you check. So I'm getting here minus 2x2 plus 3x2 equals to minus 2x1 plus 3x1. 3x1. This side we have x2, this side we have x1. Started with f of x1 equals to f of x2, reaching here x1 equals to x2. Therefore, of course, the clearly function fx is 1, 1. No doubt about this. No doubt about this. Clear? Now we're going to move on to learn about our onto function. Okay. Start with this. Simply, whenever you talk about onto function, write subject as y and the function itself. Now in this case, what is the next step? For onto function, find x as subject and find the constraint on y, which will give me the range. I'll repeat. First, you write subject function instead of y equals to that something in terms of x. Once you get that, make x subject and write the constraint on the variable y. That will give me the range. Start from here. You have xy minus 3y equals to x minus 2. X minus 3y, x minus 2. Now bring x over here and that over there. Correct? So we get here xy minus x and we get 3y minus 2. xy minus x and 3y minus 2. Take x common, you'll get y minus 1 and 3y minus 2. Continue please. You get x equals to 3y minus 2 upon y minus 1. This is my x as subject. Now check carefully. What is the constraint on y over here? What y cannot be? Y can be any real number. I can put, what can be put for y in numerator? I can put anything, sir. Nothing is a problem. It's a rational function. But y can be anything but 1. Y cannot be equal to 1. As soon as you take y as 1, it becomes y minus 1, means 1 minus 1, that is 0. In the denominator, undefined. Rational function, this is the rational function. Rational function cannot have denominator as 0. It means y belongs to all real number except for 1. Y belongs to all real number except for 1. And this is what? This represents what? This is nothing but your range. Check carefully. This is coming equal to your codomain. Here, B was codomain. So your range is coming equal to codomain. Therefore, the given fx is onto. The given function is 1, 1 and onto. Good question, worth 5 marks. Very good question, but not difficult. It's a very good question, but it's worth 5 marks. Question number 10 now. So the signum function is going to be what? 1 on onto or not, we'll see. Of course, it's not going to be 1 on onto. So if you have that, let's find from the first category of 1, 1. Let's find f of 1. The value is going to be mod of 1 upon 1, which is 1. Let's find f of 2. You'll have mod of 2 upon 2. Answer will be what? Again 1. So f of 1 is equal to f of 2, but 1 is not equal to 2. Therefore, f of x is not 1, 1. F of x is not 1, 1. What about onto function? What about onto function? Same thing. Your range you check now. Range of this function is only 3 values, minus 1, 0 and 1. Range of this function is only 3 values, because if you draw the graph of signum function, this is it. Here we have a big dot, open, open. This is 1, this is -1, and this is 0. So the range is only -1, 0, and 1, which is what? Range is not equal to the codomain, because codomain is what? All real. Codomain is, this is all real values. It means f of x is also not an onto function. Done? Not 1, 1, not onto. Question number 10 is also done. Question number 11 now. So look, I am trying to give you the question which actually helps you or gets you closer to the question that is coming to for the examination. If not the same, similar will come, but it will not be very much different from what I am giving you. Okay, I'm not studying your paper, but I'm trying my best to analyze your question banks, your model papers, your previous year question papers, and this is my conclusion. Getting it? That's why I have taken different varieties even in the same concept which is set. There will be only one question, but we don't know which one. That's why we have to solving 3 to 4 types of each category. Consider f as, so this is the domain. Domain is what, beta? Domain is given as all r plus. What is the codomain given over here? Not range, codomain. The codomain is given as, check, close 4 to infinity. I'm trying to prove that it is invertible and find the inverse of it. Okay, so for invertible function, what is the first thing? We'll try and go for the 1, 1, 1, 2. Bijective we have to prove, and then only we can find the inverse. Let's find the bijective. We'll go f of x1 equals to f of x2. When you do that, you'll get x1 square plus 4 equal to x2 square plus 4. 4 and 4 cancels. You have x1 square equals to x2 square, and you get x1 equals to plus minus x2. In this case, there is no plus minus because we don't have negative value. Positives are only there. There is no negative value. Okay. So remove this minus sign, which gives me what? Proof which is true. If f of x1 and f of x2 are equal, then x1 x2 also have to be equal. Therefore, the given function fx is 1, 1. Clear. Now for onto part. For the onto part. Okay. For the onto part, we're gonna go, as I mentioned, right, y equals to x square plus 4. Make x subject, so you'll get x square equals to y minus 4. So you get x value as root of y minus 4. Now find the constraint on y. And what is the constraint on y? That we can see that this has to be positive. So y minus 4 has to be positive or 0. It means y have to be more than 4. This is what? This is range, sir. This is range. It means that my range is coming as, please check carefully, close 4 and everything more than that means till infinity. And if you check carefully, this is coming equal to the codomain also. Range and codomain are equal. Clearly, the function fx is onto. Fx is onto. Now, the function that we have is both 1, 1 and onto. Is both 1, 1 and onto means it is bijective, so invertible. Fx is bijective, therefore invertible. Invertible. Done. Now, once it is bijective and invertible, we are also supposed to find the inverse. For inverse means f inverse of x, you will do nothing, just use the same function and replace x by y. You'll get x minus 4. X by y. Okay, means y and x will be replaced. This is your answer. But the domain and range will change. Here the function will be defined like this. F inverse of x will be defined from here. What is this going to be? 4 to infinity to r plus. Means your codomain and range will swap each other. In case of inverse, what happens? X, the range and the domain actually, or codomain and range swaps each other. Got it? So it will be reversed. If you do this much, you get full marks. 5 marks. Okay, excuse me. Question number 12 now. Question number 12, I hope this makes sense. Question number 12 is a very simple question. Okay, very simple question. We have to show that whether it is 1, 1 onto or not. Clearly not 1, 1 function. Go with the 1, 1 part. So if you go and find f of 1, you'll get, you have to go for odd, no? So 1 plus 1 by 2. Answer becomes 2 by 2. What is the answer? 1. If you find f of 2, you'll use the even part. So n by 2. Also 1. So you're getting that f of 1 is equals to f of 2, but 1 is not equal to 2. Therefore, fx is not an 1-1 function. Fx is not an 1-1 function. What about onto, sir? Let's check. As I mentioned, we'll have two cases in this one because we have two different branches of the function for odd and even separately. Let's go with the odd first. So n plus 1 by 2 is there. Let's find n subject. We'll get 2y minus 1. 2y minus 1. I'll repeat and rewrite this. Looks confusing. Yeah. 2y minus 1. N is 2y minus 1. N is 2y. If I take y equals to n plus 1 by 2, n is 2y minus 1. Now check here. Check here. If I take y belonging to any natural number, how come, sir? Because they mentioned that the codomain is what, beta? The codomain is all natural number. It means the entries of y will be from where? For codomain only, no? So for any natural number of y, okay, any natural number y, what will happen? 2 into natural number. Take an example. Y equal to 15. 2 into 15, 30, minus 1. How much is that? 29. 29 is a natural number? Yes. I'll repeat again. For any y, a natural number taken from codomain. Not clear? I'll make it easy for you. This is codomain. This is domain. I took a number 15, remember? For a number 15, what is happening? For a number 15, I took this 2 into 15 is 30 minus 1 is 29. This is mapping to a number 29. So any number you take over here, any number you take, it will have a mapping in this. It will have a mapping in this. Basic idea is all the elements in codomain will be mapped to some element or will have some pre-image in the domain. It means your codomain is actually equal to the range. None of the elements are left out. It means for odd cases, fx is onto. Means for every number which is a natural number, y, for every y which is a natural number, there exists a x or there exists a n actually which will be a natural number. I'll repeat. For every number y, a natural number, there will exist a small n which will be also a natural number. Means the mapping is true. There is none of the element left out in the codomain. Make sense? Okay. Now let's get back to the even side. Let's get back to the even side. Okay. For the even side now. Have a look. What is the even side? Y equal to n by 2. So n equals to 2y. Think logically, no? For every number y from the natural number, 2, 5, 7, whatever you take, 2 into 2, 4, 5 into 7, 5 into 2, 10, 7 into 2, 14. All these values of n corresponding to y belong to natural number will also be natural number. Therefore, again, the codomain and range are equal. Basically, none of the element in codomain is left out. Hence, even in the case of even, fx is onto. I hope it makes sense to you. In both of these cases, none of the element in the codomain is left out. Hence, both the functions are in odd and even case and onto case and onto function. Okay. Question number 13 now. Question number 13. Find the area enclosed by ellipse. A very standard definition. We have done this question many times, but it is important and we expect this one as well this year. This value is A. This value is B. We know that these parts, part 1, part 2, part 3 are all symmetrical in nature. Area of all these parts are symmetrical in nature. So if I call this area to be area of part 1, my required area of ellipse actually will become 4 times area of part 1. The area of ellipse will be what? 4 times of area of part 1. Make sense? Okay, sir. Makes sense. Area of ellipse is 4 times of area of part 1. How do you find area of part 1 then? Very simple. Area of part 1 will be given by integration of the function y dx from where to where? From 0 to a. Part 1 is the first quadrant area. I can integrate from the origin to the point A in the function that we have y. But sir, we don't have y. But we can find it. We can find the function y. How do you find that? Check here. You can write y square by b square equals to 1 minus x square by a square. It means y square by b square equals to a square minus x square by a square. It means y square is equals to b square by a square into a square minus x square. What have you done, sir? Simplification, this much all of you know. Okay, understand that. Value of y, take root now. So b square by a square will become b by a, and this will be, this is the expression of y. Makes sense, sir. Also makes sense. Now integrate. What's the integration? Constant is, sir, b by a. This is for area of part 1. Area of part 1. b by a, limit is 0 to a. Y value is this only. b by a I have taken already outside. So this is a square minus x square dx. We all know this is a particular function, no problem over here. b by a is outside. This will become x by 2. Same root will repeat. And we'll have plus a square by 2 sine inverse of x by a. You have to remember the formulas. You have to remember the formula. This is from where to where? From 0 to a. From 0 to a. From 0 to a. The formula is important, particular function from 0 to a. Have a look. a1 is b by a, x by 2, a square minus x square, plus a square by 2 sine inverse of x by a. Okay. Okay, b by a is as it is. Now put the value of a over here. When you put that, excuse me, put the value of a over here. When you put a on this side, it will become a square minus x square. So a square minus a square, 0. Put it over here, you get a square by 2 sine inverse of a by a. That is how much? Sine inverse of 1. That is pi by 2. I'll repeat. Sine inverse of x by a. Sine inverse of a by a. Sine inverse of 1 pi by 2. Lower limit. Put 0. 0 into anything. X equal to 0 if you put, whole thing is 0. Plus. Put 0 in this place. 0 of sine inverse of 0 by a. Sine inverse of 0. Again 0. Sine inverse of 0 is 0. Simplify this. a1 is coming as b by a square by 2, pi by 2. A and a cancels. You have the answer as pi ab by 4. This is the value of my a1. Do I want to find a1? No, I want to find the ae. So find the area of ellipse as 4 times of a1, which is nothing but 4 times of pi ab by 4, which is nothing but, so area of ellipse is given by pi ab square units. Pi ab square units. I don't think anybody will have doubt in this question. Okay. Question number, this is clear, guys. Question number 14 now. Question number 14 now. Okay. Find the area lying in the first quadrant and bounded by the circle. Okay. First quadrant and the circle is there. Circle is what? Radius is 2, means 0 to 2. They mentioned the same thing actually. Okay. Means they're asking us area of the circle in the first quadrant basically. We have the formula, we can find the quadrant area, but we have to prove it. Okay. So we can find the required area to be, area of the circle means we'll add the function y dx from where to where? 0 to 2. How do you find y, sir? Same approach. Y square is 4 minus x square. So y is what? Root of 2 square minus x square. Root of 2 square minus x square. Integrate. Integrate. Check. So integrating this, we'll have 0 to 2. My required area A. Okay. Correct now? Yeah. 2 square minus x square dx. Have a look. We'll have the value as, first one will be x by 2, the same root repeats, 2 square minus x square plus, then we'll have a square by 2 means 2 square by 2 sine inverse of x by 2. From where to where? From 0 to 2. Substitute the value and get the result. When you put 2 over here, this will be 0, so 0. When you 2 square by 2 is what? 2 only. Sine inverse of 2 by 2 is what? Pi by 2. No problem. Sine inverse of 2 by 2 is 1, so pi by 2 again. There comes a minus sign for the lower limit, put 0. You'll get 0 into everything is 0 only. Put 0, sine inverse of 0 will be again 0. My answer becomes A equals to, cancels, so pi square units. Okay, pi square units. If you're not sure, if you want to verify, what is area of quadrant, guys? What is area of a quadrant? Sir, pi r square by 4. What is r in this case? Sir, 2 square by 4. What is the answer coming as? 4. Please check. This is just to verify. This is just to verify. Not required to do that in the exam. Your answer ends over here. This is your answer. You don't have to solve this part. Not need to do it. Only this much is enough. Again, a 5 mark. Okay, next. So I hope I have done it many times. I have given you your short questions also. So 6 marker and 4 marker already discussed to all of you. Okay. Question number 14 is done. Question number 15 now. Find the area of the region bounded by line. Draw the line first. X is 0, y is 2, y is 0, x is minus 2 by 3. This is the curve. Okay. This is x, this is x dash. This point is minus 2 by 3. This thing between what and what? Minus 1 and 1. This thing, this is between minus 1 and 1. Let's call this to be point 1. This is what? Sir, minus 1. This is 1. So what are the required area over here? Can I shade it? Of course we can do that. So this is my required area. Okay, the negative one I'll also mark. This is the required area. Okay, so I got to integrate this function 3x plus 2. Check here. My required area will be what? Integrate 3x plus 2 from where to where? From minus 1 to minus 2 by 3, and this will result into a negative value due to the modulus sign, because this area is below x-axis. It will be negative value, so do it with the modulus sign, plus integrate minus 2 by 3 to 1, same thing, 2x plus 3 dx. 2x plus 3 dx. Make sense? 3x plus 2, sorry. 3x plus 2. What is this? This is 3x plus 2, not 2x plus 3. Got it? Let's try solving it now. So my required area is coming as, integrate this, you'll have, of course we have outside modulus. We'll have this as 3x square by 2 plus 2x. Okay. And we have here minus 1 to minus 2 by 3. Okay. Plus same thing, 3x square by 2 plus 2x, correct now, plus 2x, and minus 2 by 3 to 1. Okay, let's put the values back in. When you put this value, you'll have the modulus outside. This will become 3 by 2 times of square of this. So 4 by 9, correct now, 3 by 2 is a constant, square of this will be 4 by 9, plus 2 times of minus 2 by 3, correct guys? 2 times of minus 2 by 3. Upper limit is done. Now go for the lower limit. You'll have this as again 3 by 2, and this will be what? Simply 1. Square of this will be minus 1. Sorry, simply 1 only. Okay, and this will become minus 2. So this is the first part. Next you check for this other part. For the other part you'll have this value as same thing. Again, if you put 1, you'll get 3 by 2. You'll get plus 2 for the 1, and for this one you're gonna get minus sign will come with the modulus. Okay, with the, for the lower limit you'll get 3 by 2 into 4 by 9. Okay, and minus 4 by 3. Am I correct? Please check. 2 into 2 is 4, so minus 4 by 3. Something is getting cancelled. I hope it does. Please check. Yes. 3 3s are 9, and we have 2 2s are 4. So 2 by 3 I'm getting over here. This will become what? Minus 4 by 3. This will be, yeah, same thing. 3 3s are 9 and 2 2s are 4. Correct? Alright, sir. Let's simplify this now. Area becoming this as modulus is there. We have, sir, 2 by 3 we have sir minus 4 by 3, we have sir minus 3 by 2, minus 3 by 2, 3 by 2 minus 1 minus 2. This is 1.5 and this is 2. Difference will be minus 1 by 2. So this outside sign negative, so becomes plus 1 by 2. Check here. 1.5 minus 2 is minus 0.5. It will become plus 0.5, so 1 by 2. This is plus sign. And this will be what? Check here. 3 by 2 plus 2 will become 7 by 2. And over here we have minus 2 by 3 and plus 4 by 3. Am I right, guys? Please check. Minus 2 by 3 and 4 by 3. Makes sense? Minus 2 by 3 here and plus 4 by 3. Correct. Check this out now. So if I change the sign, because modulus will change sign. No, not necessarily. We'll take the LCM first. We'll have this value as, check, this is going to be 6, sir. This is going to be 6 over here. 3 2 ja, so 4. 3 2 ja, again minus 8. Okay. And we have here plus 6 over here with the modulus. Again take LCM now. We have this also as 6. This becomes 2 3 means 21. 7 3 21. 3 2 means minus 4 and 3 2 means again plus 8. Plus 8. Can I simplify this? We are getting this value of A as, do I have more space? Okay, I don't, but I can solve it here itself. So we get here 6 plus 4 is 10. 10 minus 8 is going to be 2 only. Okay. 2 by 6, something is wrong. Should be negative actually. 6 plus 4 is, did I miss something? Okay, not necessarily. 6 plus 4 is 10 minus 8 is 2, 2 by 6. And over here we are getting this value as 29 minus 4, 25. 29 minus 4, 25. 25 by 6. This comes as 27 by 6. I do not know, guys, whether this answer is right or not. Let me know in the comment section. I have tried to get the result. I think this is correct, but if something is wrong, some mistake in calculation, I'll review it once. Let me check once again. So 6 plus 4 is 10 minus 8 is 2. 2 by 6 is correct over here, and this is going to be 29 minus 4 is 25. Makes sense. 27 by 6 is the right answer, I think. Have a look. This is your answer. You can cancel this then in that case. 3 2s and 3 9s are 9 by 2. Right? 9 by 2. So 4.5. Something I'm missing. Please check something I'm missing. I think I'm missing something. Let me check once. Okay, so we get here. Okay, so I realized my mistake. It's a very silly one. I'll show you. You'll be surprised to see the kind of mistake I think you already observed. So the mistake is this one. 2 into 3 is 6. 1 into this value will not be 6. It will be actually 3. This will be 3. This will be 3. Sorry, I just had a look. 4 plus 3 is 7 and it will become minus 8. That is going to be minus 1 by 6 actually. So now it makes sense, guys. This will be minus 1 by 6. Yes, the mod of minus 1 by 6. Okay, minus 1 by 6. Yeah, correct now. Yes, 1 second. Looking messy. Sorry, just a second. Okay, this is going to be minus 1 by 6. So the answer becomes 26 by 6 actually. Answer will be 26 by 6. I can do better. Yeah. Yes, it will be mod of 1 by 6. Answer becomes 25 plus 1, 26 by 6. Answer is 26 by 6, which will become what internally? 13 by 2, beta. 13 by 3. Yeah. This is your answer. 13 by 3. Okay, 13 by 3. Okay, guys. Okay. Enough. Yes. Okay, so this was the mistake that I made in your calculation. It was not 6, it was actually 3. 2 3s are 6 means 1 3s are 3. That's silly mistake. 15 is done. Question number 16 we can solve now. Let's go. Question number 16 we can solve now. So this is a differential equation where dx by dy form is there. Alright, sir, we can solve it, no problem. Dx by dy is there. I can write this as y upon 1 minus y square into x, and we have a times of y upon 1 minus y square. A times of y upon 1 minus y square. From here we know that this is your p value and this is your q value. How do you find it? Integrate from here. E power y upon 1 minus y square. Correct? Right, no? Yeah. 1 minus y square and dy is there. So if you go about this, if you can take 1 minus y square as t, you're gonna get minus 2y dy as dt, minus 2y dy. Please check, if you substitute this part as t, you get minus 2y dy as dt. It means y dy becomes minus dt by 2. So this becomes what? E power integration of minus dt by t, and we have 2 over here, minus 1 by 2, correct. So e power, we have minus 1 by 2 ln t, it goes up, e power ln t power minus 1 by 2. So I get this value as, what is this? E power ln will get the effect out, so t power minus 1 by 2. And if you cancel and put the value back of t over here, you get this as 1 minus y square to the power minus 1 by 2. Okay, let me write the final answer for the integrating factor. Integrating factor becomes what, sir? 1 upon root of 1 minus y square. 1 upon root of 1 minus y square, because it is half, power is half and also in the denominator. Make sense? Okay, so once we have this, your answer becomes x times of this value 1 minus y square. Okay, now integrate, this is equals to integrate this integrating factor into that value. We have a times of y into 1 minus y square dy, y square dy. Yes, all right. So then again we can use the same result. Okay, it'll be what? Check this out. I can take this as t, it'll become whole thing as t root t. Substitution will be there, so we can use the same thing over here. You'll get y dy as minus dt by 2. You get here a is a constant and minus a by 2. This becomes y dy as dt, and over here you'll have root t into t. So we get this as minus a by 2 dt into t power 3 by 2. Okay, so integrate this, a by 2 integration of t power minus 3 by 2 dt minus a by 2 t power minus 3 by 2 plus 1, which is nothing but going to be minus 1 by 2. Okay, minus 3 by 2 plus 1 is minus 1 by 2, plus c will of course come. So my answer is nothing but, have a look, this will go up, so you'll have this 2 and 2 cancels, this minus sign also cancels, so plus a, and we have this value as t power minus 1 by 2 plus c, and this is going to be what, sir? This remains as it is, x times of, what is it, 1 upon root of 1 minus y square, correct? So you substitute the value of t back, t is what? T value is the same thing. I've used the same substitution over here also. Same have been used over here also, substitution. So I can substitute it back, you'll have the result now. I can erase and write. You'll have the result in this way. Please check the last step. You'll have a positive, of course, minus minus also cancels, right? So a positive upon root of 1 minus y square and plus c. If you check, if you multiply on this side, you'll have the final result like this: x equals to a plus c times of root 1 minus y square. Because if you cross multiply, you'll get this and this cancelled. You'll have c times of 1 minus y square as the answer. Have a look. A good question. Okay, this is question number 16. Question number 16. Have a look. Okay, now if it's something different is coming, let me know in the answer. So I hope this is the right, because I checked the mistake was over here, and this, let me know the answer for this question also. Question number 17 now. Question number 17 now. Okay, dy by dx by secant x tan x. This is simple LDE question. So I hope you can see the pattern now, what type of question will come in section D, which is 5 marker. So your value of p in this case is secant x. So integrating factor will become what, beta? E power secant x dx. Answer is e power ln of secant x plus tan x. Answer comes as secant x plus tan x. A simple question. Okay, now use it over here. You get y times of secant x plus tan x, the final answer, equals to integration of secant x plus tan x into, what do we have? This is the q value, this is the q value, this is the p value, this was your px. Okay, so you get into that tan x dx. The answer becomes secant into tan, integration of secant into tan x, and over here plus tan square x dx. One more step, secant x tan x. Tan square is what? Secant square x minus 1. Now you can integrate. So answer comes as y secant x plus tan x. This will be simply secant x square of secant integration of secant square will be again tan. So plus tan x minus x plus c. 1 will be minus x plus c. So the answer comes as y. Divide this whole thing. You'll get 1 over here if you divide these, and you get 1 minus x minus c if you take them in the numerator itself, and you have secant x plus tan x together. That's your answer. Question number 18 now. Question number 18. Okay, so find the equation of a curve passing through the origin given the slope of a tangent. Okay, dy by dx, the slope is, the curve is passing through the origin, means one of the point is given 0, 0. dy by dx is the slope of tangent, is equal to sum of the ordinate, means x plus y. Okay, alright, so I get dy by dx is there. I'm going to bring this over here, minus y equal to x. This value of px in this case is minus 1, and qx is x. Qx is x, right? Yeah. So integrating factor, check, e power minus 1 dx. So e power minus x is my integrating factor. Now once we have this, answer becomes y times of e power minus x equals to integration of e power minus x into qx is what? X dx. This is going to be application of by parts on the right hand side. Apply. Y into e power minus x equals to, I can use the condition of preference order as I let. Exponential has the last preference, x has the preference over that. X as it is, integration of e power minus x dx, minus sign will come, integration with the derivation of x, that will be 1, it will be minus e power minus x minus 1 dx on the first part, x e power minus x upon minus 1, we have minus and minus plus, integration of e power minus x dx gives me minus x e power minus x, over here again minus e power minus x plus c. This is your y, e power minus x. Okay, if you want you can remove this, you'll get value of y as y equal to, this if you can cancel from here, minus x minus 1 and plus c times of e power x. This is your answer for general solution. This is your answer for general solution. If you divide everything by e power minus x, no, or multiply everything by the e power x, you'll get this will be simply cancelled. Here also cancelled, here also cancelled. You have c times of e power x. Now substitute this value that you have, passes through the origin, means 0, 0 satisfy the curve. So put it there, 0 equal to minus 0 minus minus 1, minus 0 minus 1 plus c times of e power 0. This is going to be 1 only. From here I get c equals to, this one will come on this side, so 1. C value is 1. So my answer becomes, have a look, my answer turns out to be y equal to minus of x plus 1 and plus c is 1, no, so e power x, c is 1 means e power x. You can simplify this, you'll get e power x minus x plus 1, e power x minus x plus 1. Done. Okay, a 5 marker. Clear guys? Question number 19. Find the general solution of the given equation. A very simple one. dy by dx, you want to form the standard function of LDE. Cos square has to be moved to the other side because you cannot have anything as the coefficient of dy by dx in LDE. So you have y upon cos square means secant square x y. Here again you will have secant square x and sine by cos x. Does it make sense? Does it make sense? No, it does not. 1 second. It does not. We'll keep it as tan only. Okay, we'll keep it as tan only. I'm dividing by, check here, divided by cos square, no? It will become secant square if you divide everything by cos square. Okay. So this is your value for Px and this is your value for, whole thing is value for Qx. Right, integrating factor, e power secant square x dx, answer becomes e power tan x. E power tan x. Okay. So write the answer, y times of e power tan x equals to integration of e power tan x into secant square x and tan x. Now I got it. Yeah. Now in this case, take substitution of tan of x as t, you get secant square x dx as dt. Substitution is used. Check the question transformation. You have this one as it is only, y e power tan x as it is, and if you integrate this, you're gonna get e power t. This and this will become dt, and t will be tan. E power t into t dt. You don't have to change the LHS side. You can simply integrate the RHS separately and then use it together as an equation. Okay, if you want, you can just remove it over here as well. You can remove it over here as well. Simply write this as integration. This part has integration I, and write this for integration I. E power t dt integration, you know, I let we can apply. Again, algebra has a preference, so t as it is, integrate e power t is e power t minus derivative of t is 1, integrate e power t as e power t dt. Answer is t e power t minus e power t. So basically t times of minus 1, t minus 1 times of e power t, correct? T minus 1 times of e power t, that is my integration I. Final answer, if you club it from here, you will get y e power tan x equals to e power tan x, t is tan x minus 1 plus c, correct? Yeah. Check here, you can cancel this. You'll get answer is y equal to tan x minus 1, and you can write c times of e power minus tan x. By multiplying everything by e power minus tan x or dividing everything by e power tan x, you get the result. This to be cancelled, and you'll have c upon e power tan x. Answer is e power minus tan x. Okay, done. Next, this is clear, guys. Question number 20. Question number 20, this is the question that is unique in nature. So usually this kind of property is asked in your 4 marker, but there you have only till a squared, you don't have till a cube. But I have seen this question in your question bank. I don't want to keep any surprises for all of you. That's why this question, if it comes, will come for 5 marks, and you'll have a matrix given. Okay, I have already taken the results. So this is the result for your a square. This is the result for your a cube. Okay, how do you find a square, sir? Of course, a square is nothing but a into a, no surprises there. So a square is there, a cube is there. Once you find both the values, a square and a cube values, you have both the values, you need the value of 6a square. So can you find quickly 6a square also? Yes, we can do that, sir. Let's find 6a square. Multiply this. We have 30. We have 0. 6 means 48. I'm finding 6a square, right? 6 5 is 30, 0, 48, 12, 24, and 6 5 is again 30. 6 8 is 48. We have 6 0 is simply 0, and 6 13 is 78. 6 13s are 78. Okay, 6a square is there. Now 7a, can you find 7a also, bacha? Let's find 7a also. Let's do that. Let's see how can we solve this question. 7a. When you go with 7a, you're gonna get this value as 7 0 14 0 14 7 14 0 and 21. So you have a cube, you have 6a square, you have 7a, and you did 2i also. So 2i is very simple. 2i is 2 2 2, and rest all is 0 0 0 0 0 0 0. What are they saying? Take LHS now. LHS value is what? A cube minus 6a square plus 7a and 2i. Let's check over here. I'll write for the first term. A cube is 21 minus this 30 minus 30 plus 7 and plus 2. Check here. 21 plus 7 is 29 plus 2 is 27 plus 21 plus 7 is 28 plus 2 is 30. Minus 30 will be 0. Okay, same way if you solve, you're gonna get all the results as 0 only, and this whole thing becomes what? An null matrix with the order 3 cross 3. With the order 3 cross 3, that is your RHS. This is your RHS. Now, that's the result. 5 marker. That is it. Please check. Question number 20 is done now. Alright, let's go ahead and solve question number 21 also. Question number 21. So there will be a question on the application or finding the inverse of a matrix 3 cross 3 order in 5 marker. This is again a simple question. After the first, the simplest was from C and D, second simplest was from relation and function, third one is from this particular chapter, which is matrices and determinant. And over here the question is simple but calculation is there, so we have to be careful about that part. Check here. Lucky for us, they are saying that find A inverse, and using A inverse find and solve this equation. Okay, that's what they're saying us, no problem. Check carefully that actually if you make this matrix over here using this particular constant, you'll get the same matrix. Check. 2 minus 3 and 5. You get over here 3, 2 and minus 4. You get over here 1, 1 and minus 2. So when you make the matrix of the coefficient, you get the same matrix. 2 minus 3 and 5, 3, 2 and minus 4, 1, 1 minus 2. So remember, when we used to solve the equation, we'll have this condition. The constant will be what? 11 minus 5 and minus 3. So we used to call this to be matrix A, X and B. In this case, we can't call it matrix A. We'll call it, let's say, matrix P. We call it matrix P. So to find X, we have to find what? P inverse into B. And to find P inverse, we have to find what? Adjoint of P upon determinant of P. Lucky for us, they're saying that find A inverse first, and actually the matrix P is same as matrix A. So we'll simply find what? We'll not find P inverse, we'll find A inverse, because they're the same thing. They are the same thing. So how do you find A inverse, beta? First thing is to find determinant of A. First thing is to find determinant of A. Let's do that. Across 2. 1 second. Yeah. Across 2 you check now. So first element is 2, no? Across 2 you check. We'll get minus 4 plus 4. Minus 4 and plus 4, which is 0. Now across 3, you're going to get minus and minus, so becomes 3. This is gone. So minus 6 plus 4, that's minus 2. Am I right? Minus 6 and plus 4, that is minus 2. Now across 5 you also check. Across 5 you're going to get what value? 3 minus 2, which is 1. 3 into 1 minus 2 is 1. Check this out. Determinant of A is coming as 2 into 0 is 0. Minus 6 plus 5, which is how much? Determinant of A is nothing but, in this case, minus 6 plus 5 is minus 1. Which is a non-zero value, means we can continue to find the inverse. Means this is a non-singular matrix. This is a non-zero value. Okay. Cool. Now I want to find the value of adjoint, right? I want to find the value of adjoint. Find the value of adjoint. For that, we're going to write the matrix 2, minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. Okay. And we'll repeat this. First 2 rows, minus 3 and 5. I'm repeating the first 2 rows, 3, 2 and minus 4. This comes over here and this comes over here. And the first 2 columns also. 2, 3, 1, 2, 3, minus 3, 2, 1, minus 3 and 2. I've repeated the first 2 rows and first 2 columns to get a 5 cross 5 matrix. Once you get that, check here. And remove this and remove this. Remove the first row and first column. Now you are left with a 4 cross 4 matrix. Start multiplying in by cross multiplication in the vertical columns and write the answer in the horizontal rows. Minus 4 plus 4, 0. Minus 4 plus 4, that's the right answer. Minus 4 plus 4, that's 0. 5 plus 6, 5 minus 6, that's minus 1. Again, 12 minus 10, that's 2. Be careful, guys. 4 into 3 is 12 and minus 10. Be careful with the signs. Carry on. Minus 4 plus 6. Minus 4 plus 6. That's 2. minus 4 again, plus minus 4 and minus 5, that is minus 9. Correct? Minus 4 and minus 5, which is minus 9. 15 plus minus 4 and minus 5 minus 15 and plus 8. Correct? No? 15 and minus 8 becomes plus 8. 15 plus 8 will be 23. Let me cross check once again. 15 plus 8 is 23. Correct. Again we'll go in this particular form. 3 and 2 comes as 3 plus 2 is 5, and we get here minus 3 minus 2, this is minus 5, minus 3 and minus 2 is minus 5, 4 plus 9, that is 13. Let's cross check again. 3 minus 2 is, excuse me, my bad, 3 minus 2, no, that's 1. Yes, 3 minus 2, 3 minus 2 is 1, minus 3 minus 2 is minus 5, 4 plus 9, okay, 4 plus 9 is 13, correct. This is my adjoint matrix. Once you have the adjoint, change the sign to get the inverse. So inverse is coming as, check guys, 0, 1, minus 2, minus 2, 9 and minus 23. This is going to be minus 1, 5 and minus 13. This is your A inverse. To find x value or the variable matrix, write A inverse into B. You'll get the x value as, in this case, 1, 2, 3. Please do the product. Do the last step. Do the product. Product of A inverse and B. Please check. Okay. Do the product and let me know the answer. Comment your answer. Okay, question number 21 is clear now. Got it? Question number 22. This I have solved in top 50, guys. If you remember, solved in top 50 session, and this value of x, y, z is same question, comes for again same answer 1, 2 and 3. This comes for 1, 2 and 3. It's not the same question, but I have solved this question and answer was 1, 2, 3, I remember. Okay, so please solve this question also and verify. Solve and verify. These are the questions that come from 5 marker of this chapter, and this also 23. This is correct now. The order is right. 23. Yes. The last question. This is a proof of the property. Proof of distributive property of, of matrix multiplication. So you have to solve it. Solve and verify. These questions you need to do it from your side. It's simply time consuming. It's nothing much there in these questions. You have to just add matrix B and C. Okay, sorry, B and C, something is wrong. Yeah, something is wrong. 1 second. You have to calculate A times of B and C. Something doesn't make sense. B and C. 1 second, guys. B and C, if you're doing, how can you add B and C? B and C you cannot add because they are not possible to add, right? This question, something is wrong over here. I'll check it later. Okay, because B and C, if you're adding, it is not possible to add B and C. Something else can we try? Can we go like this? C times of A plus B, and we go like this, CA plus CB. I think this is better because A and B we can add, right? This is a mistake. I've taken from the question back. This is a mistake. I did not see it. So you cannot add B and C. C is a 3x1 order matrix and B is a 3x3 order matrix. You can't add a matrix of the which is not of the same order. So you can add A plus B. So please go and add A plus B over here. Okay, and we have to learn about what? Our method of distributive property. So we can go and learn from here also. So find CA value and CB value. You can check and verify. It is a question of verification, no? So please understand. Do not take this. Take this one. C of A plus B equals to CA plus CB. Can you do that? Please find C of A plus B. Add these two matrix, multiply that result with C, and multiply C with A and C with B. Okay, can we do that? C with A with C with B, can we do that? In this case, it's going to be 3x1, no? We cannot do that actually. We cannot multiply C with A also. We have to take matrix C in this case, in that case. C becomes what? 2 minus 2 and 3. Then it becomes 1 cross 3, 1 cross 3, then I can multiply. Okay, or I can do AC and AB then. Or I can do this one. If I'm doing CA/CB, I have to use that matrix. I have to use AC and AB. I can do AC and AB though. Yeah, but order cannot be same, no? Correct. This question, do one thing, leave this question. Okay, but my point is, this question, there's a mistake over here. I'll figure it out. But if you want to solve this problem, solve it like this with the matrix C like that. And then if I let me know. Okay, because to make it C into A, this is a 3 cross 3 order matrix, this is 1 cross 3, then you can multiply and get the result. Yes, yes. Okay, so to make it possible to, I have done the correction in the question. C is this going to be, multiply this C with this and get the result and let me know. The question is incorrect. I'll go and verify, my bad. I should have checked it before. Okay, I could edit it over here as well, but I just want to point it out on purpose that this is a mistake in this question. So I don't want to edit this part, I don't want to cut it off, because it is a recorded class. I can of course ask them to remove it, I can record it again, but I don't want to, because I want to point it out, the mistakes that is there, and it can actually come like this, and we should be able to understand how can we improvise and learn from here. So what is the mistakes? First of all, if you have 3 cross 1, you cannot multiply 3 cross 1 with a 3 cross 3 matrix. When you multiply this 3 cross 1 with 3 cross 3, we cannot multiply this, not possible. So we have to go 1 cross 3, that's why I've taken this as 1 cross 3. Okay, now somebody will say, sir, why don't we take it as AC and ABC? You cannot do that. If you take C into A and C into B, you cannot get AC and BC. Sir, check here. C of A plus B is equal to CA plus CB. It is not equal to AC plus BC until unless C and A are inverse of each other, which is not possible. Correct? No? C and AC are not equal. CB and BC are not equal. Only if they are inverse of each other. Not the case. So CA plus CB is not AC plus BC. Do not take like AC plus BC. You cannot, okay? Then what about, sir, if I take B plus C times, what if I take, sir, A plus B times of C? Then it is possible. If you take A plus B times of C, then it is possible. You can take A plus B times of C. You cannot take C times of A plus B. So basically, if I want to summarize it, if you want to find A plus B and multiply with C to get the result as AC plus BC. Too much confusion, sir, in this question? Okay, let's do one thing. I have given you all the information. Now let me make the changes. I'm going to erase everything in front of all of you. Check here. The question number 23, of course you can go back and see what I'm trying to say in the beginning also, but let me give you a straightforward answer also, what to do in this question. First of all, remove this. Now what you're going to do, find this result, A plus B. Why is it A plus B? Because we can add them. They are conformable matrix, they are a same order matrix, and then multiply C on this side, because A plus B order is what, beta? 3 cross 3, and what is the C order? 3 cross 1. Are they possible to multiply? Yes, they are. This is 3 row 1 column, so you can multiply now, and the property that should come as will be AC and BC. You can multiply 3 cross 3 to this also and this also. So try to prove this one. I gave you the mess no before this, few minutes back. This is your question, actual question right now. If you want, you can use the other category or simply use this method and get the result. I do not want to cut it. I want to keep you informed like this itself. I hope it's not too much confusion. Okay, this much clarity only comes if you know the chapter well, which I know. I hope you also know it. Okay, so there's no confusion. If you want to skip all of that, simply come back to this point right now where I'm asking you to find this value. You cannot find B plus C, beta. You cannot add B plus C. B and C are of the not the same order. B plus C not defined, sir. Not defined because they are not of the same order. Got it? Okay, so this is clear, guys. So and this is the end of your lecture. All 5 markers. We wanted to take questions as per your latest blueprint. From which chapter, what questions can be expected. I have done all of that in this question set. I hope you find this session helpful. Let me know your feedback, what you feel about this class in the comment section. And if I have missed something, let me know that as well. If you have any doubt that regarding any of the questions or the last question, don't worry, feel free to ask me about that in the comment section. We still have time. I can make amends. I can come back and give you more and more questions, more and more classes before your boards are here. So all the best. Keep working hard. Keep smiling. Till then, I'll again see you in the next class. Till then, take care. Bye-bye.